So this drawing here is a nice, clean, simple drawing, but it highlights some pretty neat advantages you can take when there's part symmetry. We're also talking about how to dimension a bolt pattern, or bolt circle, rather. So again, notice we have our overall. Always make sure you have your overall, the width, length, width, and height. Don't make those, have to be math problems. And we have a bolt pattern here, but notice up here we have a center line. So this part is symmetrical, about one axis. And we took advantage of that as the draftsman and put a center line right through there. Notice also, even though it's kind of cluttered, we put in our crosshatch or our circle center lines. And unfortunately in the PDF, the separation didn't show up, but it is there, I promise. It showed up here, obviously, because this guy extends all the way out. But what we did here is we took advantage of a bolt circle. And so there's, instead of dimensioning the width and the height and all that for each one of these, we just said there's 4 1/4-inch diameter through holes equally spaced. Equally spaced means what? They're 90 degrees apart. If there were 5 equally spaced, then it'd be 360 divided by 5. Whatever number of them you have, you can just say equally spaced. If they're not equally spaced, then you're going to have to dimension them, and you've got a strange bolt pattern or bolt circle if they're not equally spaced. So you'll have to take extra care to dimension the angle of each one or something. But this is, and then if you're going to call out a bolt circle, you need to call out the diameter of that bolt circle. And that's what this extra dashed line here does, is it calls out the diameter of the bolt circle. So while it looks like there's not a lot of information here, this is plenty for a manufacturer to make this bolt circle. Notice I have the height from the bottom to the center of the bolt circle. This is just dimensioning the height of the that flat area right here. But I have the height of the center in, let's call it Y, the vertical here. But I never said where it is in X. Well, going back to our center line right here, we said that everything on the right is the same as everything on the left, and everything's symmetrical about that center line. So they know that it has to go in the middle of this 3 inches. Now, what does that do? Well, it says that instead of us having a tolerance over here and a tolerance over here, and if the 3 inches is undersized and this tolerance is a little oversized, you may not get a bolt pattern in the middle, even though everything's within tolerance. If you wanted that bolt circle in the middle, then just pull it off of a center line. And if this ends up being 2 inches, 995 thousandths, then this will still be in the middle of that slightly undersized width. And so it's something to think about. I really like to take advantage of center lines when I can, because usually if you designed it to be in the middle, you want it to be in the middle, and you're relying on it being in the middle. You can't go in here and say, well, I want it 1.5 inches here. Oh, and I want it 1.5 inches over here as well. So that's what the center line is all about. Again, we have through holes here. If it's a through hole, make sure you tell them it's a through hole. Of course, the hidden lines do show that, but it's good to just restate it. Next, we're going to talk about how to do an exploded view, also sometimes called an assembly drawing. So we've got all these parts, and we need to show the operator or the assembler or whoever, sometimes just a person quoting on making this for you, how all these parts come together. It lets you show them all in 3 space in a 3-dimensional view with some reference to how it all fits together. So that is going to look like this. So an exploded view will usually either have on the drawing or included with the drawing some reference to these parts in terms of their quantity per the assembly, and at least their name or part number or description or something. So this is not how it has to be done. It's not how it's always done, but this is just an example of how it could be done. This could be a whole separate sheet of paper with maybe several more columns talking about what it's made out of, what its weight is, each one of those parts, what their weight, what their material, what their finish, what their cost is. It can get much bigger than that. This is a very basic kind of bare minimum of what that bill of material would be. And like I said, this isn't really a bill of materials. It's more just like oh, piece 80. What is piece 80? I can come over here. Oh, that's a cap screw. Well, on a better bill of materials, it would tell me what the McMaster car part number for that cap screw is. And, how many, well, it does tell me how many there are. And that's kind of important too, because let's say piece 110 here. Let's see, or maybe I'm just reading the list and I see piece 110. Oh, there's a plastic bearing. What is that? Where does that go? Oh, well, here it is. Oh, there's 1, 2. Okay, there's 2 of them. Wait, no, it says there's 4. Oh, that's right, there's more over here. So having that quantity is pretty helpful. Sometimes you might also have a grid on your drawing. A lot of times you'll see that on drawings like this one, where it has A, B, C, D along the side and 1 through 10 along the top and bottom. And so in that bill of materials, it might say, frame support, piece 90, and then it might say it's in D6. And so you would immediately know where to go to look for that. In this case, you're just going to have to look for these balloons, and that's what these are called. These numbers that are circled, these are circled boxes. There's different formats to that. Circles are pretty common. And that's a balloon, and that balloon is going to point to the part. There's never any dimensions. I say never. I've certainly never seen where there's dimensions on assembly drawings. Your sole purpose of this drawing is just to show how this all comes together or comes apart. You should have given all that information somewhere else. If there's a dimension or something like that, maybe you'll show dimensions on a drawing of this thing put together, overall dimensions. But this sole purpose of this is just to show how all these things come apart and come together. That being said, assembly lines are a necessity. They should be dashed. There's different ways of doing them. I think these are 2 shorts and 1 long. I think that's pretty standard, but I'm sure there's other ways of doing it. The dashed assembly line should follow all the way through. I don't know what's going on with that. Should follow all the way through whatever runs along that line. So you wouldn't want to break that line mid-stride, is what I mean. Now, what you can do when you're pulling this thing apart, let's say you had to, it didn't make sense to just pull everything left and pull everything right. It was still too cluttered and you couldn't see all the parts. Then you can pull things up and down. And that's what happened with this base plate here, piece 170 or bottom plate. It got pulled apart and down. Well, those lines clearly show that. But it also shows that when this is put together, this tab right here lives inside this notch right here. And that's clearly shown by that assembly line. On the same note, you can see that these 2 bolts, pass through these holes, and they go in this plate right here, which doesn't have holes in it for some reason, but it should. You can see that this pin goes inside here. You can see that this bearing goes into this collar. Now, it's a little crowded here because there's another assembly line that passes behind here, and it shows this one. So we've got an assembly line coming through the center of this, into the center of this bearing, into this. And then you've got another assembly line that is attaching this bar to its pocket. And so there's a little bit of clutter going on there, but obviously this shape is not going through that hole. Maybe this could have been done a little better, could have been spread out a little bit more, but you get the idea. You got to have these lines showing where everything goes together. You need to have everything labeled with balloons. And how detailed you get into your bill of materials over here is really going to depend on what your requirements are. Okay, so hopefully that was helpful. And the idea here is once you get your solid model done and you've got your design finished, you kind of know what you're looking at or looking for when you finish your detailed drawing. So you're going to have to do a detailed drawing for each and every part on your product. Now, that being said, in the future, design things with part sharing, right? Like if you can use the same part here as you use there, it's a good idea to do that. Then you don't have to do so many drawings and it's easier to manufacture. For example, this part is the same as this part, but whenever possible, that'll save you some time. Yeah, so you're going to create a detailed drawing of every part in your project, and then you'll create an exploded view, just like the one that we looked at, with every one of those parts in the drawing. Do the best you can to orient it, rotate it around the isometric. It probably shouldn't be straight front or straight top or anything like that. So when you orient it for your exploded view, you're going to want to make sure that you pick a view angle that does the best job of being able to see all those parts. And you're never going to get anything perfect. Like this beam's kind of hiding back here, but pick an angle. There's no rule about which angle it has to be. Just pick something and spread those parts out in a way that makes them easiest to see. And then that'll be it. You're going to have this exploded view, some kind of bill of materials, and all your detailed drawings. Good luck.